are going to look at mathematical methods for physical sciences. In the sciences, we concern ourselves with physical quantities that we might measure. Anything that we could measure is a physical quantity. And relations exist between any variable physical quantity. They can all find their place in a formula. And so let's look at a formula as an example. The formula that links the time period t of a pendulum swinging to the length of the pendulum L. T is equal to 2 pi square root of L over G. Now in this formula, T and L can take any real value. They are therefore known as real variables, or more simply, variables, things that can take the measurements from our experiments. This is T and L. Whereas G is different. G, representing the gravitational field strength, is always the same, and so it is a constant. In mathematics, we normally use the letters A, B, and C, the beginning letters of the alphabet, to represent constants, and the letters U, V, W, X, Y, and Z to represent variables. Let us now imagine two quantities, X and Y. Now imagine there is a way of calculating Y knowing X. There is a rule that links the two numbers. We can say that there is a functional relation linking both of these quantities. Now take, for example, a series of numbers added together, where each number is one more than the last one in the series. So, take for example 1 plus 2 plus 3 plus and on and on and on for an n number of numbers. Could we find a formula that enables us to work out what the answer is for a given number n of numbers added together? Well, indeed there is. Let's say, for starters, that S subscript n represents the sum of all of these numbers. And what we would find is a half n multiplied by n plus 1 would give the answer. But what you notice here is that this only works if n is a whole number. It takes the discrete values of 1, 2, 3, 4, up to whatever number you want to go up to. What it cannot take is 1.5. It cannot take 2.5. And so n is not a real variable. In the physical sciences, we usually save lowercase n to represent the number of things. Now we have said that any real variable can take any value that we like. But what is more often the case is that the value will lie somewhere within a certain range. Take for instance, if I was trying to measure the length of something with a meter stick. It is certainly true that there are positions this side of the meter stick that my meter stick cannot measure, and there are positions further on than the meter stick cannot measure. The presence of my meter stick means that my measurement x is somewhere between the beginning of the meter stick and the end of the meter stick, and I can represent that with an inequality. Here, x lies somewhere between A and B. Now, because of the symbol here, what we say is that x is greater than or equal to A. That means that x can be A. and also x can be b. Now what we call this is a closed interval, and we would sometimes write this as a comma b. Now what we know here is that a and b have to be real numbers. Take for instance a different situation where we did not make it a closed interval. We had a this here is an open interval, and we would write it like that. But notice now, because x cannot be either of the endpoints, it is possible to make a and b stretch off to infinity. And with that, what we have is a situation where we could say that x is anywhere in the universe. But in the first situation, x is somewhere within the meter stick of measurement.